Steepest descent optimization technique is derivative-based optimization technique. This lecture demonstrates two methods to find values of x1 and x2, which will minimize the given quadratic function, f of x. First, second gradient del first order derivative function f also called first variable given variable x2 f of x. Arrange all terms in descending order of exponential values. Find del f, which is equal to first order derivative of f of x, with respect to x1 and x2. Assume initial values of x1 and x2 as 0, 0. Solving del f by replacing x1 and x2 with 0, 0 will give s1 is equal to the negative derivative f1. Hence s1 is equal to minus del f1. Hence s1 is equal to new set of coefficients x2 is computed by adding lambda 1 s1 to the set of assumed coefficients x1. Till here both the methods are same. Two methods basically differ in computing value of step lambda. Method 1 to find optimal step lambda. In the first method we need to find matrix A. For this, given quadratic equation f of x is mapped to the new form as half of x transform into a into x plus b into x plus c. Arrange f of x in the order as terms with the x1 square, followed by terms with x1 and x2, followed by terms with x2 square, followed by terms with only x1, followed by terms with only x2, followed by constant terms in equation. While calculating matrix A, consider part of an equation up to term x2 square. Divide the term consisting of x1 and x2 into 2 equal half. Next step is little bit difficult to understand. Here coefficients represented in the matrix are the coefficients of respective row and column variable multiplication sequence. Coefficients and variables will still remain as mentioned in an original equation. This is equal to the half of matrix. This is matrix A. Matrix B is computed using coefficients associated with the remaining terms x1 and x2. This is matrix B. As there is no constant term in the given function, C is equal to 0. However, we do not need B and C to calculate value of lambda. We need only value of matrix A. Thus, the resultant function f of x is now use computed value of matrix A, negative gradient S1, computed at x1 equal to 0 and x2 equal to 0, for computing lambda as follows. Lambda 1 is equal to the S1 transform into S1 divided by S1 into A into S1. Thus lambda 1 is equal to the half. Thus, new values of x1 and x2 is minus 2 and plus 1, respectively. Calculate del f2 by replacing x1 and x2 with the new set of coefficients. Since del f2 is not a 0, this is not an optimal solution. Need to update coefficients x1 and x2. In second iteration, lambda 2 will be computed using S2 transpose into S2 divided by S2 transpose into A into S2. Thus lambda 2 is equal to 1 by 4. New set x3 of coefficients will be calculated by adding lambda 1 S1 to the set x2 of coefficients. This new value of coefficients, minus 1.5 and 2, will be substituted in an equation to find S3. If S3 is not 0, this process will be repeated again, to find new set of coefficients. This process will continue until gradient del becomes 0. The set of coefficients, where computed gradient, del turns to 0, will be our final solution. Method 1 to find optimal step lambda. Process of finding del f and s remains same. Del f1 is calculated by replacing x1 and x2 with initial assumed values 0, 0. S1 equal to minus del f1, equal to minus 4, 2. Set x2 of coefficients is computed by adding lambda 1 s1 to the original assumed set of coefficients, 0, 0. Replace coefficients x1, x2 with new coefficients, in terms of lambda 1. Take derivative of function f of lambda 1 with respect to lambda 1 and equate it to 0. Again we will get lambda 1 equal to half. Update values of x1 and x2 by adding lambda 1, s1 to it. Once again compute del f2 and s2, using new values of x1 and x2. Update values of coefficients x1 and x2 by adding lambda 2 s2 to it. Once again, write function f of x in terms of f of lambda 2. Take derivative of f of lambda 2 with respect to lambda 2 and equate with 0. Again we will get lambda 2 equal to 1 by 4. Once again update values of x1 and x2 by adding lambda 2, s2 to it. We are getting same values, minus 1.5 and 2 after second iteration. These iterations will stop, when del f reaches to 0 or, after some specific number of iterations. Thanks for watching. If you need solution for any other problem, please mention in comment box.